Welcome back for the afternoon session of the third day of the Summer Hackfest. So the first speaker this afternoon is Sci-GaIA from TERNET, the Tanzanian National Research and Education Network. And today he will tell us about his use case, that is WECA machine learning in breast cancer. Stephen.
Good afternoon, everyone. I'm Sci-GaIA. I've been introduced with Professor Roberto. I'm going to present my use case, which is use of machine learning software in the analysis of breast cancer. So the problem is breast cancer is the disease that affects a large part of the world. In Tanzania, actually, has been that statistic that is 14.4% of all reported cases is breast cancer. So we are looking on the way that we can use this scientific tools to easily determine this for those who have been diagnosed with tumors. These tumors, breast cancer, or they call it malignant tumors or benign tumors. So actually we have a data set from one common breast cancer which from UCI machine learning repository, which we are planning to use on our use case. So what actually we are going to do is to port a WECA application. WECA is abbreviation of Waikato Environment Knowledge Analysis. This is the tool that has been developed by Waikato University from Switzerland, and is containing of machine learning algorithms for data mines. So actually what we want to do is to port this WECA on the Science Gateway so that this application will be available for scientists in which want to do any kind of machine learning. But in our case, we want to be specific on the determining these diagnostic tumors that have been diagnosed already. So we want to see what percent of the diagnosed have this breast cancer, and what percent is just tumors, normal tumors or benign tumors. So what we want to use this tool, WECA tool, because it have different machine learning algorithms. So there is a way to classify the data. Like we want to classify malignant tumors against the benign tumors by using native Bayes classifier with experiment of tenfold cross validation. So there is a different classification algorithms, and we can reuse after application being ported in the Science Gateway. We can use different classification algorithms. So this is just one of selected. Actually, we will discuss with our expert, because I'm not very expert on the software, but will help me to see which other kind of algorithms can be used to classify these malignant tumors against benign tumors. So the main task is to develop the interface that will be put on the Science Gateway, which will be able or will help other scientists or other people in the society to use the tool in different scenarios. In our case, we will use our use case, which is breast cancer. So actually, when I came to Catania, I was having my own technology that I thought I will use, but I've been presented these last days with other different tools, and I'm not sure if I will go to use my technology that I thought before, but I will discuss with expert to advise me in which the best tool I can use. But actually, what I think it will be in the future gateway. So technology actually will be used is the future gateway, but and these are other tools like Docker. I thought of one data because on the mounting of data from different places to the application, because Worker use a lot of data can be used by mounted in different ways. So maybe someone wants to upload it from the local machine, or someone wants to take online in different ways. So I thought like we can use maybe one data in one way after listening to the technologies these 2 days. So the main task is to develop interface with the following features. First, they have to be able to upload data or to take data from anywhere, maybe in the cloud, and to convert the data to the format that Work understood or can work with, which is ARFF. And then another is to be able to access the classification which is on the backend, because Worker have to be installed on the backend. So on the SAS gateway, we have to create an interface to be able to access those classification and use them to make those classification of either malignant tumors or benign tumors. So the classification are like bias and others. So there are many, but we will see how many we will use on the development. Or if we are able, we can make all algorithms available. So many. Another thing is to in this data there is some of the missing. There is missing data. So what we want to use, Worker have ability to check the trend of data and to try to make assumption of the missing data. So as you can see, their effect when it fill the missing values. We want to see the effect between when there is no missing values and where there is a missing values. What are the different or what are the performance of the statistic? Okay. So in summary, just to close up, these are the things we expect after end of the development, that will be able to implement the interface that will be reused in different use cases. Also, to be able to meet our goal, like to implement Worker, so as we can try to use to classify our tumor our data in those two ways, in the malignant tumors and benign tumors, and see what the results. And also we want to port this application, because it will be developed on the Docker, so later on, at the end of the day, if it works fine, has to be ported on the SAS gateway. Also, to allow scalability in case of to move either to the mobile or either to expand to add more features like other algorithms and classifications and things like that. So that was expected at the end of the day. Thank you.
Thank you very much, Stephen. Questions? Stephen? Simon?
Okay, so observation first. WEC is a great tool, but it's got 100 different ways that it can be used. To make things within the context of this summer school, I think what would be good is to bring it down to a very simple use case, where you do this first, you do this second, you do this third, fourth, fifth, or whatever, finished. You know, so even if it's just using Weka in one way, then you can think, well, okay, I'm doing it that way, so I'm going to have this web-based front end, so that the user can click a radio button or push a couple of parameters in, and then that launches onto the Science gateway, runs Weka, produces the results, puts it in the workspace, and you can think, okay, well, next step is what's the user going to use those results for? is there a visualization you could do, or is it a sort of statistical process that needs to be done? You know, but just doing those steps and trying to accomplish that within the next week or so, I think would be great stuff.
Okay, thank you.
Any other questions? Okay, so if not, let's thank Stephen again. And let's move to the first presentation of the afternoon. As understood, there's a first part done by David, and then you will show something that is also general for other applications. So David Risinamozzi, if I'm spelling correctly, from the Northwest University in South Africa, will tell us today about reproducible automatic speech recognition workflow. David. You should wear your microphone before starting. Okay.
All right. Good afternoon. My short presentation this afternoon is going to deal with reproducible automatic speech recognition workflows. And as my name has already been said, David Risinamozzi from the Northwest University in South Africa. I'm going to deal with a few things, and one of them, this is of course in human language technologies. This is the area that we're trying to deal with. We are trying to actually assist the human language technology community to have things a bit easier done than what was currently happening. So this is just a very few slides that I'm going to quickly go through in our discussion. All right. So the introduction is what is an automatic speech recognizer? Somebody might not know what that is. I've just put a simple definition here that it can be defined as an independent computer-driven transcription of spoken language into readable text in real time. So that's basically what's happening there. It's actually popular for an HL2 community, human language technology community in South Africa. South Africa has about 11 official languages, so that becomes part of the interesting part of things. I know we don't compare to Nigeria, as Prof was saying in the morning, and I know other countries have got more languages than this, but this is our scenario in South Africa at the moment. We've got 11 official languages which we are trying to do this for. And we've got available speech corpuses that have been collected already. But of course, you know, in research, you keep on collecting more, and you keep on trying to improve on what you have. But these are the prevalent corpuses that are used at the moment of those particular sizes. All right, so within these sizes, they'll encompass all the 11 languages. The only difference is, of course, the quality of the speech data that we have there. So the requirements of a speech recognizer is these few things that I've listed here. It needs sufficient storage space for large is relative in this case, large audio and text data sets. It actually needs high performance computing, and this is a parameter sweep application which can be done in parallel. Of course, it needs many CPUs, as I'm saying there. But when you do deep neural network learning, would prefer to use a GPU, but in other cases you actually don't have the GPUs, so you need to solve that. You need to find a way of going around that. You also need high-speed internet to move data from to the compute nodes or to the worker nodes, as it's been said before, and a mechanism to manage data sets. I think those are the things that I think our application needs. All right. So the tools that are there, I've just listed a few here. There are a lot of tools. You've got HTK here. You also have got libsvm. You have other applications like Cowdy and a lot more speech applications that could be used, but we've just selected a few that I've listed here. And actually, the part that Bruce will deal with is we doing this call via Code Red, which is simply the continuous delivery of research applications in a distributed environment. That's what Code Red is basically is. Bruce will give a short demo about that to show what that deals with. All right, so the scientific problem, or what is our problem here, what are we trying to solve? Our problem is we have got lack of collaboration amongst researchers. Most of our researchers want to be exclusive, so there's a culture of exclusivity. It's like it's me and me alone, and I'm the best in this, which is good. It's good to be the best in something else, but from my early days when I was a child, I was told that a problem shared is a problem half solved. So if we could synergize these things and we could work together, then definitely we would get better results. I believe that. So we also have got a lack of exploitation of the available distributed computing resources. We actually have a South African national grid, of which Bruce is responsible for that particular platform. He deals with maintaining that infrastructure and making sure that things happen while most people are asleep. But that system is not fully utilized. It is utilized by a few, but we want it fully utilized, because why have a system and not use it? I have a few colleagues that I've worked with, some friends that I've seen their computers working for 38 hours or 40 hours trying to solve a particular problem, and that's really not cool, not in this day and age that we're in. So the research questions that we're trying to answer is, are speech recognition models reproducible? That's what we're actually trying to answer. How do speech recognition models vary according to the different dictionaries in training? And the corollary issues are the provenance and publication of models, the ease of exploring automatic speech recognition models, and access for researchers. All right, and also we want to make access to the national language resources easier. These are the things that form our scientific problem, and this is what we're trying to solve. I've just came up with, we came up with a very abstract data model here, where I'm trying to explain some few things. It's very highly abstracted. You forgive me for that. But what I've seen in the past 2 days, and of course in some of our discussions with Bruce just before now, we actually use GLibrary just a bit. We just started trying to use GLibrary. But we have there an open access repository where it's not just GLibrary which is there, it's actually where we want our data, we want to throw in our data there in the open access repository, and we want to also have all the things that we need to store there, like if we get results, can we store them using GLibrary? It's part of what we want to actually have a look at in the next coming 2 weeks. But you have that center rectangle which has got the corpus, the dictionaries, the parameters, and run. This whole image is, I think the missing thing is, this whole image is within a web interface. So it's encompassed by a web interface. So you've got that, you're taking your data from your open access repository where you've got several corpuses stored, you've got several jigs stored there. You bring it to a space within the web interface where you play around with parameters, and then you push it through the system. Once you push it through the system, it goes to the Science Gateway. Science Gateway will push it down to the worker nodes or the slave nodes, and some processing happens there. From there, you want to store your results in your open access repository. And in the open access repository, what we actually want to do is to have the parameters that gave this particular results bundled together with the results to say if anyone wants to check, they will see that if I rerun this with these parameters, I will get the same. And if I want to improve on this, maybe I need to change one or two things there. And that's what we're trying to do. All right. So this is what needs to be done. The ASR tools are working, but there's of course a lot of integration for a research environment which is necessary. We also need to do the data ingestion into the open access repository. Of course, the dictionaries, the copy, and of course, the web interface needs to be developed where you select all these dictionaries, the corpus, select what task, define parameters. This is just an overview of the diagram that I just shown. Of course, the validation and comparison, that is important. We need to be able to validate other people's research. I think until we get to a point where research cannot be validated, I don't think it's good enough research. So if it's good research, what are we afraid of? Let's put it in the open and let someone else come and test it and validate it. That's what research should be about. Of course, most importantly is, of course, the publication of new analysis, the new models, the new accuracy. In an automatic speech recognition, you're worried about the accuracy of the system to do the recognition. So a higher accuracy, it means that the system performs better, it can recognize almost anything. So we need to be able to improve on that. But if we publish it, then of course we can always improve it and build on what's there already. So these are some of the things that need to be done. The implementation strategy, of course the web interface that has to deal with the scheduling and training of jobs using the specific data sets and the recipes encompassing. Applications need to be ported to the South African National Grid. It's a platform where a researcher in South Africa can actually boast that the fastest computer in Africa is in South Africa. It's actually 121 in the world, the Lingao computer. So we do have resources, and the government and research institutions are trying to get things out there so that people can do more research. But I've also, as I've been saying, we also want to use this open access repository. The One Data platform is a good option to do this, to go through the One Data platform. Indigo is actually quite cool. Indigo is quite cool. I like the platform as a service that it provides. I like the infrastructure as a service that it provides. But I think in our case, we have people actually having a problem with distributed computing in general. So to even push them to a cloud platform, many researchers will be quite resistant on that. So I think starting to build slowly would be better. So if we can invite them to the grid and they play along and they see that they actually derive a benefit from the grid, then we can always build on that. So Indigo, I think for us, would be very, very good to use in the upcoming future. Of course, the Science Gateway, which of course, for now, I think a Science Gateway will just be good enough for us. But we're going to already start working on it with the idea of extending it to a future gateway quite soon. Because now, the Science Gateway is there, it's working. But we have seen the nice presentations that were given, and we can see that the future gateway is the way to go. So we're going to develop this in such a way that we already have the future gateway at the back of our mind, but we want to start with the basics first. All right. And the other thing that I actually saw is that the Clipper workflow management system is actually a good option for defining your workflows, and because within your ASR template, you've got so many things that call each other, so many scripts that call each other. You've got this that does text normalization, you've got something that does something else. So in the template, within the template, there are a lot of things that happen there. So a workflow management system like Clipper could, in the future, go a long way in helping us implement this better. Funny enough, there is no, I don't know what happened to this. Oh, but it's there. Sorry. Oh, okay. Now it's here. So these are the goals that we're trying to achieve, and in our summary, we're simply saying, look, we need to collaborate more, we need to exploit what's there, and we also need to automate many processes as much as possible. And of course, the encouragement of that use of Indigo cloud services in the near future is quite important for us. I don't know if there are questions for me, or I should allow Bruce to come and give a few short presentation.
Well, I'm going to take a bit of time to move over, so why don't you take some questions?
Yeah.
Yeah, thank you very much. Thank you very much, David. Questions to David? Simon.
What do you hope to achieve in the next, as part of this Hackfest?
Yes.
What's your main goal? What do you hope to achieve?
The main goal here, Simon, is to
It's a certain virtual machine file system, and it's a very similar file system to what's used by Docker. If I press tab, you don't see anything, and if I go down, okay, this is the name of the repository. If I request a file that's not there, it automatically gets staged. You can see the network was doing a bit of thing there, and I've got build 196. So that's build 196 of the entire platform. Let's see what applications are available. Okay, these are all of the applications which we have in the repository. Okay, so these have gone through the build, test, integration, and deployment phase. So let me show you how we get there. This is for the users out there. Okay, so if you go to africa-grid.org/code-rate, you'll find out the information. Okay. There's a quick start for those who want to provide the applications. In other words, you may have an HPC, a cloud, a container-based site, your laptop, whatever. This is totally platform independent. That's how to get it set up. And for users to be able to mount it on your laptop is this. There's a bit of description of the project as well. Okay. What you see again down here is all of the applications and their various states. Okay. So here you can see this is the actual state of the application right now. If it hasn't been built yet, if it's been built and it's passing, some of them are failing, and so on. Okay, and these are all kept in a list on africa-grid.org/applications. Now let's say that's nice. You can use these applications. If I want to use one, I don't have MPI on my laptop, for example. So I want to test something with MPI. I just do this. And I can see I've got many different kinds of MPI. I've got OpenMPI 1.8.1 built with GCC 4.9.2, or that same version with a different compiler. If I want to see different compilers, I can see this. So what compilers have I got? I've got GCC 4.9.2, 1.0, and 5.2. I've even got LLVM, if I'm not mistaken. Oops. Okay, so if you do use a different compiler entirely, so you can build your environment on your laptop and test things locally before sending them off. Then you write your scripts, how they're supposed to be done, and they obviously go into a GitHub repository. Not this one. That GitHub repository may look like this. Okay, so this is the libsvm support vector machine deploy repository that we had. As you can see, it doesn't actually have the application. It's just got 3 scripts in it: build, check, build, and deploy. And those are executed by Jenkins every time a change is sent to the repository. Okay, so let me demonstrate that for you quickly. I've been working on Gadget, which is a smooth particle hydrodynamics for astrophysics, and it's not building at the moment. So I wonder why. I know the problem is in here because I'll show you now how I know that. Okay, and in fact the issue was with the module file which is created over here. So I'm just going to make a trivial change that. Okay, I'm in the directory. I do git commit. And I push that change. Now you're obviously going to see my password, but I'll give you many beers if you can remember that. 32 character string. Right, so I push the change. I think that's going to work. This is not good. So smaller. Alright. The event has actually been pushed to our Slack instance. Gadget deploy. Changes started from Bruce Becker right now. Okay? And that's Jenkins talking to me. We don't like the name Jenkins. It sounds kind of tasty, so we call him Testing McBuildface. And Testing McBuildface has automatically opened issues to track the status of the run on GitHub. Right? So I know now if there's a run fails, then I can go and tell why and close that. Right? So let's click this and open it, see where it takes us. It takes us to the job. Just by pushing a commit to Git, I'm triggering a job on Jenkins. Okay, so if I want to know what's going on here, you can see that the builds on Scientific Linux passed the previous time, but the builds on Ubuntu didn't pass. Now these are the two targets that we have, and we can have as many different kind of targets. That's the end, let's say, execution environment that the job may run on. So we can define as many targets as we like, and we can even go down into the console to see what's happening and eventually find out why that broke. Okay. So I know now that it's passed the build, and this is the test phase. It's actually running the simulation at the moment, and eventually it may or may not fail. I expect it to fail because I haven't done much. All right, so here you see the tickets that have been opened on the board, and I can kind of move this into in progress now. If you click on this, you'll see that this ticket was actually opened by Jenkins itself. Here it is, saying, "Hey, you're proposing a change. I'm going to help you track it." And I can write here whether it passed the build or not. Okay, so when things pass, that's always a happy event, and we get messages in CodeRaid channel as well. Last night I was hacking away at Gadget, and so I just want to show you what happens when things pass, because continuous integration is very well known, and it's a very good idea to test your code, but that doesn't mean it's going to be available at the place where you need it to execute. Right? So here last night, an application called Abinet passed. All the tests finished, all the run had finished, and that triggered a transaction of our repository. Okay, so this version that you saw here, build 196, that is directly linked. That is directly linked to events on Jenkins. Okay, and in fact, this is build 196. So Jenkins told CVMFS, hey, you've got a new application that's coming in, I've tested it, it's going to work on Scientific Linux and Ubuntu and whatever else I've tested it on, please ingest it. CVMFS says, okay, great, I will do that. It does the transaction. We get told that everything's happening, and magically I have the application on my laptop. Okay, so the message here is that if you have a new application, and it may depend on a bunch of modules that you don't want to have to build yourself. For example, there's a huge dependency chain for many applications which depend on HDF5, NetCDF, OpenMPI, etc., etc., etc. Many of those modules have already been tested and integrated. So you just build your last bit on top of that, and it goes into the repository. Okay? There's no magic here. We didn't write any of the software. We just plugged Jenkins into GitHub, into CVMFS, and Slack, and all of the other stuff. So anybody can do that. All you need to do is open a GitHub repository and start writing changes to your files and sending commits. Okay, I just want to show you one more, which I think is a pretty cool thing. So with David, we hacked the jobs a little bit to talk to us in Slack because we were working here. And I'm just trying to find where they were. Okay, so every time a job ran, it would kind of tell us which version of CodeRaid we were using. Remember, this was a while ago. This was build 149. What the job was doing. Okay, so what data set we were using, which working order was running on, the staging time. This was the start card, and then there's kind of an end card as well. So how many CPUs I was using, processing time, and so on. This was the answer we were looking for, the separation between the two parts of the support vector machine. And yeah, so this was actually the answer that we were looking for. And this is the kind of thing that we want to kind of automate a bit more in terms of what David was talking about. So if you have an application that needs to be executed at the end of the day, Octave, Glueplot, whatever, it can be built into a repository like this that has understanding of its execution environment. And all you need to do is express how to build it. That's all. And you can really easily share those because they're all expressed on GitHub. Every time we have a new release, the release gets published, we get a DOI, you get a publication, blah, 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 blah. Okay, so that's the demo.
Thank you very much, Bruce.
All right.
I think that what we could do, I think that we all some information we already have have it, but we can try to collect actually the code executable that need to be run, and we can put in code.
Exactly.
Okay, so now we can move back the camera to the usual place, and we are going to have the next speaker.
So I'll be here all week. Sorry.
Luca Martinelli from ICCU, from the Central Catalog of Italian Libraries, and he's going to talk about implementation of e-culture science gateway reload.
Se no, sì.
Mi dà la presentazione, mandala a me.
Aspetta, no, c'è la mennetta.
Okay.
Sorry,
We use
always.
my computer. No problem.
I don't have the attachment for
HDMI.
No, I have it, but they don't have the adapter.
Okay. So, si chiama? Okay. Okay.
So, good afternoon, everybody. I apologize in advance if I will not be so brilliant, but too much sun and I'm a bit dizzy still from lunch. So, I'm talking on behalf of my institute, which is the Central Institute for the Union Catalog of Libraries and Bibliographic Resources, ICCU. And our experiment that I will briefly expose to you, it's about a digital library, Musei d'Italia, Italian museums, digital museums actually, which is a showcase of digital objects and their related metadata regarding cultural heritage, and especially cultural heritage objects, which are collected through various museums in Italy. So we're trying to revamp our whole workflow, as you read here, with the possible objective of scaling our revamping also to other projects. So we're making a bit of an experiment about this this digital library in order to move to other ICCU projects. So. Briefly on that, it's Musei d'Italia is a digital library, as I said. It's integrated into the ministry-sanctioned official portal from the Ministry of Cultural Heritage, which is called Cultura Italia. And it's a digital library based on the Fedora Commons with its repository Its repository is accessible through the REST protocol, and data sharing, mostly with Cultura Italia, is available with all the protocol OAI PMH. As you see here, there are some statistics about it. So the description of the museum actually comes from the National Registry, which is called the Places of Culture. The ministry called it that, Luoghi della Cultura. Which is, as I said, a ministry-sanctioned list of archaeological parks, museums, and all the other cultural heritage interesting sites in Italy. And then we host more than 400 digital collection made up of more than 95,000 digital objects. Both the digital objects have been digitized especially for Musei d'Italia, or they have been previously digitized for other reasons, and then we just collected or gathered them. So very briefly, these are our system requirements, and this is a bit of our system architecture. I wanted to talk about it, but I will probably grace you from this, and then probably only with the people who are going to actually actively ask on the architecture. We will discuss this part, and I will go straight to the. These are the different level of access that we have inside our platform. So we have the end user, which is actually any user. Any of you can go to culturaitalia.it and basically browse the data, search them, read them, and so on. Then there are the collection manager, which is a registered user, so possibly someone in the cultural institution, which is partner to Musei d'Italia and then Cultura Italia, which uploads or gives us actually the content. Uploads the contents to the repository and then manages the collections and the digital objects themselves. And then we have the administrator, which is our institute in the person of Tiziana Scasselli mainly, and then also Antonio Davide Madonna and other people who actually have the grant the coherence between the collection, validate all the data that are provided just formally, and so on. So I already said, okay, so basically of this slide the most important part is the central part. We have actually two different free downloadable softwares, which are the METS generator and the METS validator. So the METS generator generates those records, generates a record for every digital object and then for the collection itself, in order to create a package that should be uploaded to the server. And the validator validates actually that the XML output from the generator is actually corrected. There are some sort of standards to be followed, also like the UTF-8 codification for language and stuff like this. So it's just a formal passage. I'll go straight to the workflow now. So we collect the objects from our partners. This content is fed into the METS generator and is organized into METS packages in compliance to the standard that Musei d'Italia uses. That means, of course, that images and metadata have to be structured in a certain way. I will not go so specific on that, and then I'll just move to the second step, which is the validation of the package. Both these steps, the creation of the package and the validation of the package, can be done by the institution, but mostly are done also by our institution in order to be sure that the package has been created in the right way. So the validator software just checks the XML metadata, doesn't change anything. It just gives you an error if it's compiled in the wrong way, or it says, okay, it's good to be uploaded through FTP to our central repository, which is, as I said, Fedora based. Then the digital library administrator links the package, so the collection is actually linked to the logo della cultura, to the museum identificator. So that, you know, just to make an example, the Archaeological Museum of Catania sends us a collection of digital objects about, I don't know, Roman jewelry found in a supposed necropolis, right outside. And then so they digitize the documents, they send us the images, they send us the metadata, they do all the steps, and then we just put them inside the repository, and then we link the collection to the page, to the identificator of the Archaeological Museum of Catania. This allows also Cultura Italia to periodically harvest all this data and to put them into our official Cultura Italia portal through the OAI BMH protocol. So these are our most important problems right now. I'm going to what really you are interested in probably. So the data collection, generation and upload phases are almost entirely on us. When I said that the institution actually can do this, they do it, but then they need to anyway to pass through us in order to upload their data to the repository. We need more calculation capacity in order to scale also our possibility to scale our work and the elaboration of METS packages, and so also the uploads. And also, if there are corrections or modifications or any kind of upload of descriptive, any kind of correction of descriptive metadata on the platform, the process is a bit slow. So we can actually, we already identified a couple of places where we can improve actually this process. So our strategy, I'm really sorry I didn't put out a timeline for that, but we are already deciding how to move to the Indigo solutions. Since our workflow is basically linear, very linear, so you have to do this in order to do this in order to do that. So we plan to integrate for the separate phases of our workflow. We're thinking to integrate several of the solutions that we saw in the last days. So for the data collection phase, we are thinking about to move to one data solution in order to allow our partners to directly upload their content on one data, in order so that automatically after probably using the Kepler tool. So every time that a new institution uploads a new collection on our one data reserved space, through the Kepler tool, the system actually generates the metadata package. Of course, we will ask the institutions to structure the information in a certain way in order to smoothen the process. So in order that the data generation, validation, and management phases can be actually automized, more automized than they are right now. So we are thinking about also adopting a virtual machine. I put Ophidia here as a possibility, but I still want to use the next days to talk with more of you in order to integrate as much as possible and to understand if this is really possible or not. And also we will need to adapt probably the user level of access part that I showed you yesterday. Also because we're thinking about moving to a federated access possibility, but we need to understand how the Fedora platform can be integrated to the Indigo solutions, and then how the federated access process can be put into all this revamping. And this is the last thing. This is I said to be analyzed, because mostly the first 3 points are the things that we are going to focus about before the end of the year, very very quickly. And then, if it's possible, we are trying also to add this function for the collection manager to correct their metadata if they find that they made a simple mistake, like well, this object is a painting of 1537 instead of 1536. So just mistakes like this, they are a bit harder to be corrected, and we want to find a solution also for them to correct this kind of problems in a more smooth way, in a more easier way. That ends my presentation. I hope not to have bored you too much, and of course I'm open to your questions. I hope to be sufficiently ready to answer them.
Thank you very much, Luca, for this. Questions? In the wrong place. So just to to be sure,
Yeah.
because we already discussed some of this point. The idea is that you are going to drive this process from your web portal, or we need to build another web portal that implements some of the actions that you want to do.
This is something that we want to actually understand.
Okay.
This is
Because we already have a portal that other people you showed me to upload things, to
yeah, we already.
check that everything
Yeah,
is correct.
we would like to keep as much as possible our actual portal. Just to, but we want also to use the Indigo solution to scale about the computational process, and also possibly to, in a hopefully not so distant future, also discuss with other potential partners, and then smoothen the process for them to apply to our platform.
Because as far as I understood, some people at different museums,
Yeah.
they send you something.
Yeah, they physically send us things.
If you look this from the Indigo point of view, the idea is they will put something on one data, on some area.
Yeah.
Okay. Then, as far as I understood, there is a Kepler process. Mika, can I draw your attention? There is a Kepler process that waits to know if there is a new content somewhere, and if there is something new, triggers some process. I mean, execution or some check. I mean, building of metadata, building this package that they need to build, and then you can upload this on Fedora.
Of course, this is something that we want to understand if it's technically possible. But
Okay.
this is actually our idea, to use as much as possible all this automated process, and also, in order to reduce our burden, and then to say to people it's that easy. Once you upload things on one data, then everything is automated, and
Yeah, I mean, the idea of one data is that, yesterday we saw it. If you build a common space where the museums upload something, and you see that there are some contents in some directories,
Exactly.
okay, then you can run the workflow that does different steps in one step after the other, and produce what you want. So in this case, Kepler should not be running all the time. So somebody should check. So you run Kepler, Kepler checks that everything is new. If there is something new, it does something in a sequence.
Exactly.
Okay.
Yeah, transforming is way.
Yeah.
You can just, using a typical approach like a clone, you can just run Kepler workflow in the background, and you can already create
Every night, for example.
Yeah.
for example, and you can have the full workflow which will be executed, and as you say, if it will, in the first actor, it will decide that there is nothing new, then just finish the job and that's it. If there is something new, then proceed with the rest of the work.
Exactly.
That's perfectly fine.
And then
I wanted to ask you if it's possible to schedule this kind of.
Well, I wouldn't use Kepler itself for scheduling the task, because it's you would have to keep it alive all the time. I would just go with solutions which are already working like from
Okay.
and I would just run in the background the workflow, because there is no point to keep the whole machinery just for the sake of checking something. Whether
Yeah.
it's there.
Keep it in the background every time it triggers
Yeah.
it goes.
I mean, as you explained me, there is someone who checks this right now.
Yeah.
So this person could just either run Kepler, or just waiting for the output of Kepler running in the background.
And then she can check.
Because I understood that at the end there is a human check before things go into the repository.
Exactly.
So so you can prepare everything. So one data, people put something on one data. Kepler checks something new, prepare something. Then the person could just make the final check and press a button and publish on the repository.
Yeah, we can set up the workflow like this.
Yeah. So what you would need from Miguel is an example of a workflow like this, and from one data, the building of a common zone where you can invite all the museums, people from the museums to be able to upload contents.
Yeah.
Okay. And we have some, the strategy is more or less clear. Thank you very much, Luca.
Thank you very
Unless
much.
there are other questions? No? It's okay. Thank you very much. And we move to the next speaker, and then we will break after the next speaker. So the next speaker is Professor Benjamin Aribisala, if I pronounce it correctly, from the Lagos State University in Nigeria. And he will tell us about intelligent medical image analyzer. You want to use my computer?
Yes.
Ah, okay. You can show your slides here. Okay,
You
great.
charge me a lot of money for borrowing your computer.
Okay, so let me where is it? Okay, this one. Okay, let me put it on the desktop for the moment, and then I will put it in the right place. Okay, so I can give you back your your pen. Okay, and then I can start with this one. Okay, and you can either sit or stand, but you should do this here, okay? As soon as you wear your mask.
Okay, so good afternoon, everybody. This afternoon I will be presenting on a project that we just started, and the idea is to develop an intelligent medical image analyzer. The outline. So I just give us some background information about the project, and then I go to the motivation in form of the scientific problem and the aims and the objectives of the work, and then I'll present the use case, and then followed by the workflow, the implementation strategy. Under the implementation strategy, I will just tell of some of my plan for this trip, and we see how it goes, and then I will wrap up with the summary and conclusion. Okay, about the study background, medical images are images acquired from humans or animals. By this I just mean we talk about clinical or preclinical images, and then these images are generally used for medical diagnostics, for monitoring of patients in terms of how they respond to treatment, and then but the thing is that there are so many types of medical images, and they cut across depending on the anatomy or what the researcher or the clinical expert is interested in. So like the leftmost image here is a brain scan acquired using magnetic resonance technique, and we can see, of course, the ultrasound there. So there are different types of images, and all of the people will have the opportunity to put their own images, and so they can compare, with ours, and above all, they can use the tools on the platform to process their images. So without necessarily being a computer scientist, you can use the tools, and you can focus on your research while you are